All right, hey guys, let's do this. So, lesson 13. We should have our books here, and it should be, oh, that's not the page. It should be right over here. Trigonometry in the complex plane. So, how do we take what we learned in trigonometry in the coordinate plane and transfer it here? Okie dokie. So there are a few things that I got to show you before we actually go into the lesson. What I'd like you to do is first have the learning intentions down. And we're going to be learning this new representation, a polar representation. And what do you mean by polar? We'll get to that soon. So please have these two down and then we'll begin, right? And so just some review from the previous lesson that if I take a complex number, each complex number a plus bi corresponds to a point AB. So what does this mean? That if I take a complex number such as 3 plus 4i, right? 3 plus 4i is right here. But if I wanted to just make that into a coordinate point, it's just 3, 4. Like negative 2 minus 4i, this is my a, that's my b, this is my x and that's my y, this is my x and that's my y, this is my x and that's my y. And that's all I'm saying, is that you could take any point in here and make it into a coordinate point, or you could take anything from here and bring it over there. Okie dokie? Okie dokie. So let's also remember that let z equal a plus bi. This symbol is the modulus of z, and this is the formula to calculate it. And what does it mean again? It means that if I have a point over here, it's the distance from the point to the center, okay? Now this we need to have in our notes. And if you're looking at it right now, you're like, what on earth is going on? But you have to be patient with me. So what does it mean to have a polar form of a complex number, right? If I have this complex number, what is the polar form of it? And it'll be r times cosine theta plus I sine theta, where r is the modulus of z and theta is the argument of z. And just right here, I guess you're freaking out a little bit, but it's okay. It's okay. We got this. We got this. We got this. So have this down and I'll explain what it means. Okay. So here, when we talk about theta, right, in the coordinate plane, what did theta represent? Theta represents the counterclockwise rotation in degrees, right? So if I'm here to here, right, remember, if I'm going 30 degrees, right, if I say theta is 30, right? Or if I want to find sine of 30 degrees, what do? I just rotate 30 degrees and I just make my line, right? This theta is represented in the coordinate plane. This symbol that you saw over here, arg z, this is the argument of z. And these two are the same thing. The argument in the complex plane is basically the same in the coordinate plane. It's just the rotation from here to here. And what we do is we call this the argument of z. It's saying the degree of rotation with respect to the origin. Okay, you could copy this down. So don't freak out by if I say argument, it's just talking about rotation in the complex plane. Okay, that's all. Okay, let's move on. And what do we want to do? Here we had this idea, let me get the paper right here, that we're going to take some polar form of a complex number. So one thing we need to understand is that r will be the modulus of z, and how do we convert some complex number into this form, and why is it useful? So you have to kind of just go with me a little bit, and I'll explain everything, and things will start clicking, okay? So first, how do I get this to look like this? So here, what do we want to do? We want to calculate r. But what does r equal? Here, as we had it before, r is equal to the modulus of z. So how would I calculate the modulus of z if my z is equal to negative 3 plus 0i? Well, remember, the modulus of z is equal to a squared plus b squared, right? So here, what is my a? My a is negative 3, and what's my b? It's 0. So I just plug these in. So this is negative 3 squared plus 0 squared, and this just becomes 9, which is 3, right? And doesn't that make sense? Because where is negative 3 plus 0i? It's right here. It's just 1, 2, 3. And what does the modulus represent? It represents distance from here to here. So this distance is 3. Okay? So congratulations. Yay, we did the first part. We got r. Now it says calculate the argument of z. And what did we say before? This basically means the rotation from the initial point. And don't forget that we always start from here. So how much rotation did you do to get from here to here? It was just 180 degrees. So now we just put it all together. Here we know r is equal to 3, and we know our argument of z, the argument of z is equal to 180 degrees. So we just put it into our formula, r cosine theta plus I sine theta. And here, let's just substitute. Oh, that's an ugly looking 3. So it's 3 times cosine of 180 degrees plus I sine of 180 degrees. And that's it. We did it. But then you're like, okay, what was the point of this? Like, who cares? What does this representation mean? So here, why is polar form useful? We'll get to it in a second. But why does this equal to this? And why is it helpful? So here we had this originally. Now here it says 3 times cosine of 180 degrees plus I sine of 180 degrees. If I say, hey, what's cosine of 180 degrees? What's sine of 180 degrees? Okay, well, if I'm over here, right, it's what's this point over here? One thing we need to remember from last year we did was the 4 corners, right? Like if this is the first corner here, this is 1, 0, this is negative 1, 0, this is, oh, whoops, that is not 1, 0, that is, whoa, pause. That is 0, 1, my bad. That's 0, 1, and this is 0 and negative 1, right? And always remember my cosine is my x value and my sine is my y value. Here, what is cosine of 180 degrees? It's negative 1. Right? Oh, this should be negative 1. What's sine of 180 degrees? It's 0. So let's substitute these two values into this, and let's see what happens. So here, 3 times, what's cosine of 180 degrees? That's just negative 1 plus I times 0, right? So this just becomes negative 3 plus, what's 3 times 0i? It's just plus 0i. So it's negative 3 plus 0i. And notice how this is the same thing as this once we fill it out. And the reason why this is important for us, because in polar form in the complex plane, we're given this 3. And remember, what does this 3 represent? It represents that r. And r shows us distance, right? It shows us the modulus of z. And it shows us the degree in rotation, okay? So it gives us 2 things in one format. But how to go from this format to the next, so you just need a little bit of practice, okay? What I want you to do is try and do this one by yourself. And by the way, this is, where is this in the book? Oops. This should be right over here, on this page over here. So we're on page S.52. And what I did was, I did the first one for you, and you could do the second one by yourself. I should have probably done this stuff too, but I think maybe a little bit later, because this stuff gets very confusing. And this, yeah, we could do it later. But for now, what I want you to do is just practice this. Try and get this into polar form, all right? Try and do it by yourself. So let's see. What would you do first? Calculate r. What is my r? My r is, well, my z is equal to 0 plus 2i. So r is equal to the modulus of z, which is equal to the square root of 0 squared plus 2 squared, which is equal to the square root of 0 plus 4, which is equal to the square root of 4, which is equal to 2, right? And geometrically, this makes sense because it's just this distance from here to here is 2. And remember, this is 0 plus 2i, right? So my r is 2. Calculate the argument of z, and the argument is just the rotation. So this is 90-degree rotation. So now we just put it all together. And what's my formula? R times cosine theta plus I sine theta is, well, just put it in. So it's going to be 2 times cosine of 90 degrees plus I sine 90 degrees. Okay? And the check, why does this equal to 0 plus 2i? Well, we just go back. Where is cosine of 90 degrees? Here, we always just look at this format here. Cosine of 90 degrees, this is my x value, so cosine of 90 degrees is 0, and sine of 90 degrees is 1. So here, I just have 0, and I have 1i, right? This is 1, this is 0, and this is, hold on. Here, what was I going at? Yeah, so cosine of 90 is 0, sine of 90 is 1, and then when you multiply it out, 2 times 0 is 0, and 2 times I1 or 1i is just 2i. And then notice how this is the same as that. Okay, and that's your check here. What I want you to do is, just to get a feel for it, try and do these on your own, and then we'll move on. And if you're thinking, we got this, right? But it will get much more difficult.